My dear students, in the today's session, I am going to teach you about the insulin. Insulin is a peptide hormone, anabolic peptide hormone, and it is produced by beta islets of the Langerhans of the pancreas. Beta islets of Langerhans of the pancreas. And it is having about 51 amino acids. Its molecular weight is 5,808 daltons. 5808 daltons. And this 51 amino acids is in the form of two chains, chain A and chain B. Chain A is having about 21 amino acids. Chain B is having about 30 amino acids. And these amino acids, a few of these amino acids are the sulfur containing amino acids like cysteine, cysteine and methionine. These sulfur containing amino acids, they are helpful to form the disulfide bonds between the A chain and B chain. Seventh amino acid of the A chain links with the seventh amino acid of the B chain by disulfide linkages. 20th amino acid of the A chain links with the 19th amino acid of the B chain by the help of disulfide bonds. Extraction and purification of the insulin. As I told you, insulin is obtained from the beta islets of the pancreas, whereas alpha islets of the pancreas, it produces glucagon. Insulin reduces the glucose level, glucagon increases the glucose level in the body. Let us proceed for the extraction and purification of the insulin from the pancreas. Generally, we prefer porcine or an animal like oxen or sheep. Okay? Collect the pancreatic gland immediately after slaughtering of the ox or sheep and keep for the frozen conditions. Why we have to keep in the low temperatures, like freezing temperatures? Pancreas is having trypsin also. This trypsin may destroy insulin. If you keep at a low temperature, very low temperature, this destroying can be stopped. Next, collect this pancreatic gland, cut into small pieces, mincing. And to that you add 95% alcohol. Finally, it is adjusted to a strength of 60% alcohol. Menstruum here is 60% alcohol. Menstruum means solvent for extraction. Right? As you know that insulin is less soluble in concentrated alcohol. And in the next step, you add hydrochloric acid. Hydrochloric acid is added to adjust to a pH of 3 to 3.5. Insulin is amphoteric. Hydrochloric acid is added to adjust to a pH of 3 to 3.5. We can extract insulin both by using the acids or alkalis. It is amphoteric in nature, but whereas generally we prefer the hydrochloric acid only. In the next step, proceed for the filtration of the extract and adjust to a suitable pH. Collect the filtrate, adjust to the suitable pH and evaporate under reduced pressure. Why we have to evaporate under a low pressure? Alcohol boils or evaporates at 78.3 centigrade. We want to remove the alcohol here. But if you keep a temperature of 78.3, insulin gets denatured. So we have to reduce the pressure. We can reduce the boiling point of the alcohol. We can proceed for the extraction. We can remove the alcohol by this process. Next step, collect this product after this step and proceed for the chilling. To chill out or to precipitate any fatty matter. And proceed for the filtration of the fatty matter. You add sodium chloride or trinitrophenol for salting out the insulin. For salting out the insulin, you add sodium chloride or trinitrophenol. If you are using trinitrophenol, you will get the insulin picrate. Insulin picrate is formed here. And in the next step, you add suitable acid and proceed for the adjustment of pH to 5.2. Why 5.2? It's the isoelectric point. What do you mean by isoelectric point? The pH at which it is electrically neutral. The pH at which it is electrically neutral. Adjust the isoelectric point so that insulin gets precipitated here and dissolve in the water, and you adjust you add the buffer and add zinc chloride. That's the preparation of the, or I can say extraction and purification of the insulin. That is, collect the pancreas, and you keep for the freezing conditions to avoid destroying of insulin by the trypsin. You add alcohol of 95%, adjust to 60% finally. Insulin is less soluble in concentrated alcohol. Add hydrochloric acid to adjust to a pH of 3 to 3.5. Insulin is amphoteric. We can extract both by using the acid or alkali. We prefer the acid only. Proceed for the filtration or centrifugation. Collect the supernatant or filtrate and adjust to suitable pH and proceed for the evaporation under suitable pressure, under reduced pressure. And finally proceed for the chilling of this to remove any remaining fatty matter. And proceed for the filtration, and you add sodium chloride or trinitrophenol, which is the process of the salting out. If you are using trinitrophenol, you will get the insulin picrate, and adjust the pH to 5.2, which is the isoelectric point at which it is electrically neutral. You add zinc chloride and add the buffer solution. This is the extraction and purification of the insulin. What are the various injections of the insulin? The first one, insulin injection. Generally, we prepare either 20, 40 or 80 units per ml, depending upon the condition of the patient, depending upon the glucose level, depending upon the age of the patient, depending upon many factors, we have to choose the dosage of the insulin. Dissolve the insulin in the acidified water, which is at a pH of 3 to 3.5, and which is having a glycerin at a strength of 1.45 to 1.75%. Dissolve the insulin in an acidified water which is at a pH of 3 to 3.5, which is having glycerin at a strength of 1.45 to 1.75%. So pass through the bacterial proof filter, and you add the antiseptic, that is 0.25% phenol as the preservative, or I can say antiseptic, and store at a low temperature above the freezing point, but don't store at the room temperature. At room temperature, it is losing the potency very fast. So if you store properly, you can keep the potency for about 2 years. And this insulin injection, whatever you have prepared now, it causes the rapid fall in the blood sugar, which is not required, which may cause some hypoglycemia also. So what to do for that? We have to add some ingredients like protamine, zinc, like this, so that we can prolong the action. We can prevent the rapid falling of the blood sugar. And if you are using it as such, there is a possibility for the rapid fall and transient action, and there is a fluctuations of the blood sugar level. As the plain insulin injection is causing a rapid fall in the blood glucose level, there is a need for the prolongation of the action of the insulin. We have to avoid the fluctuations in the body, in the blood glucose levels. So for that, the alternative they suggested, that is the protamine zinc insulin. We add the protamine sulfate and zinc chloride to the insulin preparation. Protamine, what is protamine? It is obtained from the sperm of a type of the fish, that is trout. And zinc chloride also, it is used here to prolong the action of the insulin. Okay, we'll see this one. By adding the protamine and zinc to the insulin, we can make it less soluble in the subcutaneous fluids. And we can make it slow absorption. We can prolong the action of the insulin. prolong the action of insulin. What is the formula for this one? Insulin, depending upon the condition of the patient, age of the patient, you specify the units per ml. This formula is given for the 100 units of insulin, right? Protamine sulfate, we add about 1.1 to 1.5 mg per 100 units. And this is obtained from the sperm of a fish like trout. Zinc chloride at a strength of 0.2 mg, which is equal to the zinc chloride is added at a strength of 0.2 mg of the zinc. This is for 100 units. And you add the glycerin 1.45 to 1.75%, and sodium phosphate at a strength of 10 mg to 11 mg for 100 units. And finally, you adjust the pH of the solution with sodium hydroxide or phosphoric acid to get a pH of 6.9 to 7.3. This is one type of the insulin preparation.